Can you tell me? Just simple question. Try to think. So first of all, the IB4, when we say it's 32-bit, how many addresses we can have? Simple math. Okay, let me make it easier. Now, if you have 2-bit format, we are using 2 bits. How many option here we have? So let's say you have S0, S1. How many option? 2 options when you have 2 bits. So what about if what I have when I have 0, 0? That's one option, correct? What's the second option? 0, 1. Then you have 1, 0. What else? 1, 1. Okay, how many option? 4. 4, it's equal to the power of 2. So now if I have 32 bits, how many addresses I can? 2 to the power 32, which equal 65, around 65 million. All right. Now, in this current days, do you think the 56, I'm sorry. Oh, 65, correct. Millions. Do you think 65 million is enough to cover all these devices now with the technology? Everything is connected to the internet. Even now you have the fridge, it's connected to the internet, correct? What else you connect? The watch, now it's connected. So currently, the 32-bit is enough, but with the time, we'll not have enough IBs. Okay, that's why they introduced the new version of the IB, which is IB6. And what is the size of the IB6? How many addresses you will have? 2 to the power, which is a lot. Okay, so currently we're still using that's the common now. Still we're using version 4, but in the future, mostly we have to switch to the IB6. All right. So today we will cover IB4. All right. Is there a question? All right. So what we will discuss in this chapter, we'll introduce the concept of address space in general and the address space IB4. We just discussed that. We say in general we need addressing. If you want to visit a house, if you want to go to any house, you have to have an address. Okay. If I tell you, you have to go to Fairfield University, I have to give you the address. Okay. So, and you have to have a unique address. You cannot give same address to 2 houses. Okay, you will be confused. All right. So that's what we have to discuss. Then we'll discuss something called classful, IP addresses. And at the end of the chapter, we will discuss the classless IP addresses, and we'll see what's the difference and why we need the classless, why we are using classless addresses now. Then we'll discuss the idea of hierarchical addressing. I will show you what we meant by that. Then I will explain the subnetting and supernetting. That's a very important concept. Subnet and supernet. Okay, and why we will see what's the difference and why we need them. Why we need the subnet and why we need the supernet. And you can tell from the name subnet what subnet mean. You have network. When you have a subnetwork, what that mean? You divide your network to a small networks, correct? What about supernet or super network? So it's mean you're trying to combine networks and make them as a bigger network. All right, the opposite. So okay. Then we'll discuss the classless addressing, and we'll see why we use it. Why we have to use the classless, because it's going to solve a problem for us, and we see what's the problem and why we have to do that. Then we'll talk about some special block and special addressing. Then finally, we'll talk about something called NATing. NATing is technology used for a specific reason, and we'll see why. All right. So, as we said, each device, you have to have an address. And this address has to have two, specification. The first specification has to be unique. Why it's unique? It's called identifier. So if there is two hosts, they have the same ID or same address, that means it's not unique. It's not, you cannot identify them. All right. So, and the other thing, it has to be universal. What's mean universal? Universal, that's mean you need all the other system to understand this address. You need, if you're talking to different network, still they will be able to communicate. That means we understand all this, we are following the standard and we understand the format of the addressing. So again, it has to be unique. And what else? Again, has to be defined only one connection to the network. So define and give address to one. Addressing system must be accepted by any host that want to connect to the internet. So if I have host A and host B, they have to be universal to be able to communicate to each other. All right. So that is kind of one of the questions in the exam. How many bits for the IP4? And what is the IP4 has to be unique and universal. And we said how many IP addresses we have in the 32-bit. So 4 trillion, maybe, if you can read the number. So maybe 40 trillion IP addresses. Currently, that's enough, but in the future, maybe we have to switch to the IP6. Okay. And what is the base 2 and base 16 and base 256? So we'll see what we mean by that. But keep that in your mind, 256 equal 1, 1, 1, 1, 1, 1, 1, 1. It's 8 bits and all of them ones. Okay. What about base 16? Base 16, that's mean we divided 2 4s. All right. And what is this number in the base 16 or base hexadecimal? When you have 4 ones, it's the F. Okay, and the hexadecimal, remember, the hexadecimal, it's 16 numbers. So it's 4 bits, correct? So you'll have from 0 up to 9. Then after that, A, B, C, D, E, F. Okay? So the 0, how we represent that in binary, the 0? 4 zeros. Perfect. What about the F? 1, 1, 1, 1. What about the A? Easy. 1, 0, 1, 0. Keep that in your mind. Okay. So, and A, it's equal 10. How you know that's equal 10? All right. So usually what I do, I will write this number 2, 4, 8, 12. Correct? No, it's 1 up to 4. Okay. So now if you want to make 10 of that, what you have to do? You have to find the numbers. When you add them together, you give it 10. So which number you add and it will be 10? 8 and 2, correct? So you put 1 here and 1 here and the other 0. That's 10. Okay, what about 9? So 8 and 1 will be equal 9. That's equal 9. Okay, that's how you convert from decimal to binary. So keep that in your mind. But in hexadecimal, A, B, C, D, E, F, which is equal 10, 11, 12, 13, 14, and 15. All right. We'll see why I'm trying to explain that for you because we will use it now. Okay. All right. So the IP address 4, it's how many bytes? 4. So you divide it to 1, 2, 3, 4. And each byte, how many bits? 8. You have 8, and you have 8, 8, 8. So 8 multiply 4 equal 32 bits, correct? All right. So now how you present the IP4? IP address, it's what they call it is the dot nation. So what you can do, so either you write it by binary or you just convert that to a number. What is this number? It's 31. What this number? It's 3. So it's converted to 3. What is this number? 11. And this one, it's 128. All right. So for example, this one, how I know it's 31? Can you tell me? So it's simply, again, what we do, we'll do 1, 2, 4, 8, 16, 32, 64, 128. How many? 1, 2, 3, 4, 5, 6, 7, 8. Now we add the ones. Any number has ones, we add them. So what we have 1 plus 2 plus 4 plus 8, 1, 2, 3, 4, 5 plus 16. And if you add those, will be equal 31. All right. So now if I ask you how you know that's equal 3, because it's 1 plus 2 and the remaining is 0. So that's why 3. Is there a question how you find the number? Easy. That's I'm sure you know that from digital design. Okay. So what's the IP address? How you write the IP address usually? You do it 10.20.30.0, for example. All right. So usually it's just 4 numbers and you do dot between them. Clear? That's how you write them. Now a question for you. Now let's find some, let's convert them as we just did. So here the question for you, convert from binary to dot decimal. How you do that? That's going to be in the exam. I will give you a number. I'll tell you what's the IP address, how you convert it. So simple, this one you convert it to a number. This one, how much equal? That's going to be equal 239. How we know it's 239? How you find this number? Simply again, 2, 4, 8, 16, 32, 64, 128. Then which one has 1? So this one and 1, 1, 1, then 0, 1, 1, 1. So what's the number you want to add together? So you want to add 1 plus 2 plus 4 plus 8 plus 32 plus 46 plus 128. Okay, so then that's equal to, it's 239. So that's the number here. What this one? That's 11. It's easy. What about this one? It's 11, correct? So, and just that's same example. I just want to spend time on that. So what you have to do, just you find the right number and add them and find the what they call it, dot decimal nation. So in the exam, I will give you a question. I will give you binary nation and ask you to convert it to dot decimal. Okay, can we do the opposite? If I give you the dot decimal, ask you to convert it to binary? Yes, simple. Here. So if I give you this number, I ask you to convert it to decimal. All right, I'm not going to take it. I will take the easy one, 7. What is the 7? Remember the 7 is 0, 0, 0, 0 because it's 8-bit. Then you will have 0, 1, 1, 1. Is this one equal this one? Because that's the 7. All right, simple. What about if I tell you the 12? What is the 12? Is that 12? That's 12, right? It's 8 plus 4 equal 12. From here, 8 plus 12. Again, that's digital design. I'm trying to make it easy for you, but it's really simple. If you have a challenge, just go spend 10 minutes, 15 minutes, and learn how to convert from decimal to binary, from binary to decimal, from binary to hexadecimal, okay? Let's continue. All right. Now let's find some errors. Don't look the address. Let's the answer. Let's go up there. So what is the? Don't look here. What is the error here? Can you tell me what's the error here? Because remember, in the IP address, if it remember it's a 3-digit, you can do a 3-digit. But if it's 0, you don't have to write this. So you keep it without 0. What about here? What's the error? So you have 5 decimal numbers, and we know it has to be only 4. What about this one? The issue here, because remember, let me write it here. So again, the first issue is here. There is no need to write 0, right? What's the issue here? The issue here, because we have 5 decimals, we should have only 4. Okay, what about here? That's the issue. Why? Can you tell me why? Because remember, the 8 bits, when you do 8 bits, 1, 1, 1, and 1, 1, 1, 1, what is this number? That is 255. So the maximum number should be here, 255. This one, 301, which is more than 255. There is no way. 305, that means you need 9 bits. 8 bits is not going to be enough to represent 305. Okay? So any number above 255, that's wrong. So all the numbers, the maximum number you can see 255.255.255.255. That's the maximum. Which is that's mean everything is 1 here. Same thing, everything is 1. That's the highest. Same thing, all of them. Okay. What is the third one? What's the issue here? You cannot mix between binary and decimal. So either straight binary or straight decimal. Okay. All right. So sometimes we use hexadecimal. So what's the difference between hexadecimal and binary? We just divide it to not to 8 bits. We divide it to 4 bits each. Okay. So if you look here, how we can write that in decimal? We divide it to 4s. Okay, divide it to 4s. And for example, what is this number? When it's 1111 is equal F in the hexadecimal, correct? What about 1110? That is E. What about this one? That's B. What about this one? That's 0. What about this one? That's B. What about this one? 0. What about this one? 1. What about this one? Not. That's 8. Okay, if you see the answer, that's the answer. So, and there is 2 ways to write them. Either you add 16 at the end, that's mean we know it's a hexadecimal number, or what we add at the beginning, 0x. So if you want to write it, you write it. So I already found it here, correct? So I will do FEB0 B0, correct? 1, 8. Perfect. Then I have 2 options to present it by as a hexadecimal. Either I write 16 here, a small 16, or I do 0x then the number. All right. Clear? So if I ask you what about this number, can we write it together? So what you have to do first, you divide it to 4s. So that's F and F. What about this number? That's the 11, which is B. What about this one? 1. What about this one? 3. What about this one? 8. What about this one? 1. What about this one? No, that's 12, which is C. Perfect. And then to make them hexadecimal, either I will do 16 here, or I will do at the beginning, I will do 0x. Here. So in the exam, you will know. I'll give you IP address, tell you, convert it from binary to decimal or from binary to hexadecimal. So that's one of the question exam. All right. Now, that's another example. Find the number of addresses in the range of the first address is, that's the first address, okay? And the last address is this number. So what we're trying to do, I'll give you a range. I'll tell you that's the first IP address and that's the last IP address. Then I will ask you how many addresses we have there. How many computers I can connect. So how you do that? Simply to subtract, all right? So what you will do, okay, you will subtract them. You will do 146, 102, 32, then 255, minus 146 dot 102, I'm sorry, dot, what else? 29 dot 0. So subtract, it's going to be 255, 32 minus 29, 3, and 0 and 0. Perfect. So then what we have to do, we multiply this one, you multiply it by 2 to 56 power of 0. This one, the second number, 2 to the power of 256 to the power 1. Then the last one, third one is power 2, and the last one is 3. And we multiply it by the numbers. The first one is 0, second one is 0. Okay, 3 here, and last one is 55. And then we add 1 at the end. Perfect. So when you multiply 0 by a number, what's the answer? 0. 0 multiply a number, 0. 3. So 256 power of 1. What this one? 256 multiply 3. Okay, it's gonna be 700. How much? 68. Okay. Then a plus what? 256 of 0. That's 1. So plus 255 plus 1 and equal 124. All right. So that's one of the question. I will give you first IP address, last IP address. I will tell you how many addresses I have there. So the question, the process, it's really simple. You subtract the two numbers from each other, then you multiply it by the power of the location of the number, and you add plus 1. Any question? Ask. If you have a question, please. If it's not clear, let me know. Okay. Another example. The first address in the range is 14, 11, 45, 96. If the number of addresses is 32. So we're adding a 32. So that's the range. I have 32 addresses. And the first IP address is this one. So how you will know what is the last IP address? Easy. First of all, the 32, let's represent it by decimal, which is 0.0.0.32. Perfect. Then what we will do, we'll add them together, which is 14, 11, 45, 96, 0, 0, 0, 0, 32. Okay. What's the answer? 96. Okay. 128, 45, 11, 14. Okay. Then what the last step is? We'll do minus 1. That's when it's going to be 27. Because remember, always we start from 0. So when you have 32 addresses, you start from 0, it's end with 31. Because 0, it's extra. We're not starting from 1. If you start from 1 and you have 32 addresses, that means it's going to end up to 32. But since we start from 0, the addresses start with 31. That's why we do a minus 1. So again, what we did, we subtract them. Okay, and base of 2, then we subtract that by minus 1. Okay. Another question in the exam. All right, let's talk about some operations we need. We have to, I'm sure you know them, okay, because we need them later. So first operation is the NOT. Can you tell me what is the NOT operation? The opposite. So if your input equals 0, the output will be 1. So if you remember in the digital design, we have this gate. That's the inverter or NOT. So if your input 0 here, what's the output? 1. If your input here 1, the output 0. The opposite. If you give input 1, output will be 0. If you give 0, it's output 1. The opposite of the input. Okay. So we'll see why we need it. Okay. For example, that's an example. That's the number, the original number, and I will ask you to find the complements. We call it complements or the NOT. So what is the complement of this one? Simply what we have to do. Just, do the opposite. If it's 1, make it 0. If it's 0, make it 1. So 1 becomes 0. 1 becomes 0. 0 becomes 1. So the opposite. So you do all of them the same thing. If you try this one, 1 becomes 0. 0 becomes 1. 0 becomes 1. 1 becomes 0. 1 becomes 0. 1 becomes 0. 1 becomes 0. 0 becomes 1. Right? So that's in the binary. So easy. Binary because you deal with 0 ones. Now, what about decimal? So we have something called shortcut. So in the decimal, how you can find the opposite or in the complement of that or the NOT? Simply, there is no need to convert them. So remember, what is the maximum number we will get here? When you have everything at once, what is the maximum? 255. All right. So 255. What is the number you added to this 35? And there is the answer will be 255. So 2 ways. Either you can do 255 minus 35, which is equal to 220, or you say, okay, what is the number if I add it to 35? The result will be 255. So it's up to you. You can think about it this way or this way. What about this number? Same thing. If I'm not giving you that, don't look to the answer. But if I give you 14, what is the complement of the 14? So simply 255 minus 14 equal to 41. If I give you this number, what is the complement of the 17? It's going to be 255 minus the 17, which is 238. Okay. Just that's we did not use them in the real, example. We just learning the operation. So we just covered the NOT. We call it NOT. You call it complement, inverter. It's up to you. So if it's binary, it's easy. The 0 becomes 1, or the 1 becomes 0. If it's decimal, we try to find the number to reach out to 55. So either you subtract or you add. Perfect. That is the NOT operation. Now let's talk about the AND operation. What is the AND operation? And just digital, simple digital. Don't think about it. Okay. Output equal 1 when both input is 1. So that's simple theory here. If you have A and B 1, then the output will be 1. Otherwise, will be 0. Simple. So if you have 1 1, the output will be 1. If you have 0 1 or 1 0 or 0 0, the output will be 0. So that's why if both zeros 0, if it's 0 0, if it's 0 0, if both ones, then we'll have 1. Clear? So same thing. Now let's try IP addresses. So if I give you this first number, and I ask you to AND it with the second number, okay? So what we have to do simply, go find that where's the 2 ones, then make it 1. So I will here what I will do. I will start looking for where's both ones. Okay, none of them is not one of these is 2 1. So the result will be zeros. And what about here? Oh, here I have 1 and 1. So result 1. I have 1 1, result 1. Anything else will be 0. Same thing here. Here's 1, 1, 1, 1, 1. Anything else will be 0. So you will do the same thing for all of the bits. Okay, that's the first. That's if it's binary. Binary, it's easy because we add 0 ones. Now let's talk about decimal. I give you two numbers, okay, and just think about it. So I know the answer is 0. Perfect. Hi, how are you? So I know the answer is 0, but can you tell me when you add a number with 0, the answer will be 0. Okay. So again, when you add a number with 0, result will be 0. When you add a number with 255, the answer will be the number. So that's meaning we're always taking the smallest. So if one of the numbers, keep it like this, if one of the numbers is 0 or 255, okay, we will take the minimum or the smallest. Let's do some example. Here, you're adding 35 with 0. What is the lowest? That's why we have 0. Now I'm adding 17 with 255. What is the lowest? That's why my result 17. Right? Now, in the other case, when both numbers, not 0 and not 255. So in this case, okay, can you tell me how you add them? Can by just looking, can you add them? Now this number, look here, because I have 255, I can tell right away it's a 17 answer. Here, because I have 0, I can tell right away the answer will be 0. Here, because I have 255, I can't tell because I'm looking for that. I take the smallest number, 255. But here, I don't have 0 and I don't have 255. So here an exception. Here we have to do small math. We cannot just do a simple by lot. Okay, how we do that? Simply, we have to transfer them to numbers. So the 14. Let's start with the 14. The 14. How you make 14? Remember, we have the equation 0, 1, 2, 3, 4, 5, 6, 7. Which, if you remember, as I wrote before, which is 1, 2, 4, 8, 16, 32, 64, and 128. Now, if I want to make the 14, which one I need? Which one I have to make? 14. So I will have 8 plus 4 plus 2. That's now I have 14. Anything else, I will keep them 0. Perfect. That's the first number. Now, what about the 140? So always when you see a number, high number, grab the highest first. So I will grab 128. Okay, then I will keep adding, see if that's enough. 128. Can I add 64? It's going to be too much. So that's why I keep it 0. I will keep 32 is too much. Okay, 16 will be too much. It's going to be more than 140. Then I have 8. 8 plus 128, 136. Okay, we close. So I will put 8. 4 is enough. I will add 4. Yes. Okay. Do I need more? I already have the 140. So that's 0, 0, 0. Then just you add them. Not add them, just see where simple add, the logic add. So when you have 0, 0, will be 0. 2 with 0. When you add 2 with 0, remember, when you have anything with 0, it will be 0. Add 4 and 4. Just you grab one of them, 4. 8 added with 8, it will be 8. 0 with 0, 0. 0 with 0, 0. 0 plus 0, 0. 0 with 128, 0, because is when you add it with 0, always 0. Okay, what is the total we'll have? Which one? 8 plus 4, it's 12. That's why we have the result here. All right. So what we call this method, it's called shortcut. Binary, it's easy. When you do binaries, easy because 0 ones. But when we come to decimal, we have three scenarios. If you AND it with 0, result will be 0. If you AND it with 255, I will take the minimum, the other number. The third one, which we have to do more calculation, when both of them not 0, not 255. Okay, then we have to do this operation. Clear? And we will see why we need that. Okay, that's just simple operation for a reason. We will use it later. So far we learned the not or the complement. We learned the and. Okay, let's go to the or. What is the or in general from digital design? If you have one, any one of them one, the result will be one. If both zeros, the result will be zeros. Simple. Okay, so let's do some operation again. Okay, again, look, number binary, it's easy. When you see one, then the result will be one. So since I saw one, I don't care about the other. I will be one. It's gonna be 1 0 0 0 0. Then I will have 1, then 0 0. If you grab this number, if you have 1 1 1 1 1, the result will be 1 1. If you OR it with 1 with 1. Now let's go to the decimal. Easy. If it's 0, if one of them 0, you take the max or the highest number, which is 35. That's why I grab the 35. What about here? I will take the 255. What about here? Because I have 255, I will take the 255. What about this one? We have to convert it. And if you remember, when we converted before, I did not put it here, but we can go back. Let's go back and we do it together. Okay. So, actually it's good to come here because I don't need you to see the answer from there. Okay. So we just convert them. It's the same way. When you convert the 14 and 40, we will have the same box here. Okay. That's the same. But the result is different. I'm not going to look at this one. Can you tell me now, when you OR them, 0 0 0, when you OR them together, what's the result will be? 0. 2 with 0, what's the OR? It will be 2. 4 OR with 4, it's going to be 4. 8 OR 8, 8. 0 0. And when you add them together, 128 plus 2, it's 130, correct? And you will have 12, correct? 142. Is that the number we have there? Okay, that's why we have 142. Perfect. So we learned the third operation, which is OR. Complement and an OR. All right, so why we need them, we'll learn it now. Let's go to the class. So remember the IP address 4, we say it exists and we are using that because still we have enough IPs. In the future, maybe IP4 will not be enough. We need more IPs. That's why maybe we'll start using IPv6. And how many bits for IP4? 32 bits. What about the IP version 6? 128. All right. So initially, when they came with the IP4 in the 1990, they divided two class IP address or a classful IP address. All right. And they divided to 5 classes. Class A, B, C, D, E, F. So there is no F. A, B, C, D, E. 5 classes. Okay. And a class, let me go for that here. So they divided for a class, and class A almost has 50% of the IPs. Class B has 25%. Class C has 12.5%. Class D is 6.25%. And class E is 6.25%. All right. So in the network world, we are using class A, B, C. A class D and a class E is not used. The class E is reserved. It's reserved for now. Nobody uses that. Class D is for multicasting. Okay, when you do broadcast, using that. All right. So in our network, either our network is either class A, B, and C. We'll see the difference between them. Okay. So class A is to the power 31, correct? how many bits we said we have for the IP address for 32? Okay. So however, how many IP addresses for class A I will have? 2 to the power 1. There is 1 bit missing here, and we'll see why. What about the class B? Is 2 to the power 30. Okay, class C is 2 to the power 29, and this one 28, and this one 20. And as we said, you know, it's going to be 2 trillion here. Here's going to be maybe 1 trillion here, maybe half trillion, and here quarter trillion, and here quarter trillion. And that's the percentage wise. All right, clear so far? All right. Now, if I give an IP address, that's why we say class full, because it's a pre-design. You can't tell right away and what type is this one. So in the class full, okay, if the IP address starts with 0, the first bit start with 0, that's class A. Right away, when I give you an IP address, tell you, can you tell me, is this a class A or class B or class C, class D or class C? Okay, so what you have to do, just convert it to binary and look at the first bit. If it's 0, that means it's class A. Okay, if it starts with 1 0, it's class B. If it starts with a class 1 1, I'm sorry, 1 1 0, it's class C. And same thing, 1 1 1 0, the class D, then 1 1 1 1, it's a class E. So simple. Or what you can do, you try to memorize this table. If the IP address, remember the IP address is a 3-bit, like for example, 10.10.10.10. So you have to remember the first one. If this IP address is between 0 and 127, you will know right away it's a class A. If it's from 128 to 191, you will know it's a class B. If it's from 192 to 223, it's a class C. From 224 to 229, it's a class E. Or from 240 to 255, it's a class E. Clear? So there's 2 ways to know if is this IP address, it's a class A, B, C, D. Either I convert it to binary, then I look to the first 4 bits, for, let's say. If it's the first bit is 0, it's a class A. If the first 2 bits it's 1 0, it's a class B. If the first 3 bits is 1 1 1 0, that's a class. Which one? No. Maybe it's a mistake.
Like a class E and class B.
Yeah, I got you. I'm looking for the number there. It's overlap. Yeah, that number is not correct. Yes. So I have to look at that. To what? Oh, maybe 239. Yeah, maybe 239. Oh, yeah, we'll say it now. But 239, let's say. Okay, yeah, correct. Because you know, from 40 to 55, it's 15. 224 to 39, 15. Okay. So here, what is the range between here to 40 to 55? It's 15. And from 224 to 39, it's 15. So that's 239, not 299. Okay. Good catch. I never paid attention. Okay. So again, one of the questions in the exam will tell you, I will give you an IP address, tell you, can you tell me what is this class? A, B, C, D. Simple. All right. So the other way to check if this if this class A, B, C, just to follow the chart, this chart. So what you can do, you check the first bit. And if the first bit is 0, then you will know right away it's a class A. So if I give you IP address, start with 0, 1, 1, 1, 1, 1. Okay. So I will look at the first bit. If it's 0, It's class A right away. If it's not 0, if it's 1, I have to look to the second bit to decide if it's a class B or I have to continue. So if the second bit is 0, so I already now I have 1. I received 1. Then I will look to the second one. The second one, if it's 0, that's class B. Correct? I can decide right away. If it's 1, that means I will have 1, 1. Can I decide which class is 1? I cannot decide because I have to look to the third now. I have to look to the third one. If the third one is 0, I will now class C. But if it's 1, can I tell? I cannot tell. I have to check the fourth bit. If the fourth bit is 0, I will know it's a class D. If it's not 0, that means it's a class E. All right, simple. So how many ways you have to check? 3 ways. All right. All right, so let's do some exercise here. Can you tell me? Can you tell me, is this, don't try not to look to the answer. Can you tell me what this one is, class A, B, C, D? Class A, why? Because you know right away the first bit is 0. What about B? Class E, because 1, 1, I cannot tell. First, when I see 1 is not enough, 1, 1 is not enough, then 1, 0 is a class C. What about this one? Class B, because 1, then 0. What about the last one? Class E, simple. Or what the other way? How the other way you can do that? What this number? It's 1 dot something, correct? What about this one? That's 128 plus 64 plus 1. 128 plus 64 plus 1. 13 and 9. 193. 193 is a class C, right? That's another way. All right. So one of the in the example I will in the exam you will have a question similar like this. No, I'm going to give you a practice test now. Yeah, that's a practice test. Midterm, it's going to be question similar to this one. I will give you, I'm trying to. So if you see every class, I'll tell you that's coming in the exam because I already have the exam ready. So I'm telling you what's coming. All right. So maybe it's going to be the week after. Not next week, the week after, correct? Not next week, the week after. Okay. Okay. Now let's go to the other one. What is this one? Class A, B, C, D. Can you tell me? If you remember the table, remember class C? That's class D. That's class D. Why? Because D, remember D is between 224 to 239. Okay, what about this one? It's easy, this one. C, because again, 192 to 232 is C. 14, class A right away. 252, that's the last one, class E, all right? So easy. All right, IP address in a class A, B, C is divided into net ID and host ID. Class D and E are not divided into net ID and host ID. All right. Why? Okay, now we'll say that. So remember now, remember when if you want to go to a country and divide the country to states, correct? And the state divided to cities, and the cities divided to houses, correct? So now let's say now I comparing the net ID with the country. So I'm sending a mail to a country. So your net ID, it's equal the country code, for example. So we'll show you now an example. So now what is the net ID for class A? The first byte is the net ID for class A. So the first 8 bits or the first byte is the net ID. The remaining is the host ID. Okay, we'll see why, but keep that in your mind. Now, what about class B? Class B is the first 2 bytes is net ID. And remaining is the host ID. Class C, first 3 bytes is net ID and the host. Class D and E, class, I'm sorry, D, it's multicast address, and class E is reserved, nobody using. Okay, clear so far? Okay, so what we mean by that? So why we need the net ID and why we need the host? So net ID, it's going to give you the address of the network you're going to. All right, so that's going to be the main address for the whole network. And then the host ID, it's going to give you the specific address for the host. Each host, they will have address. So now let's talk about class A. Class A, how many bytes we use? First 8, correct? So the first 8, how many? First 2 power 8, correct? Which equal 128. That's mean what that means? When you have 128 option, the first byte is for the network address, and we know it's the first byte is 8 bits. And how many options when you have 8 bits? 2 to the power 8, which is 128. Okay, what that's mean? That's mean I can have 128 network, and each network will have how many hosts in each network? Remember, we use the first 8 bits. So how many bits left from the 32? 24. So how many hosts I can have in this network? 2 to the power 24. All right. So in the class A, I can have, okay, up to 128 networks. Is that correct? No, because we did so 2 to the power 8, how much? To 28. When you have all ones, what's the answer will be? 255. So we'll have 255, correct? However, if you remember in the class A, the first bit always has to be 0, correct? So that's mean that from the 8 bits, the first one is always 0, we cannot touch. Then how many bits it's going to define my network, the number of networks? 7 bits. So what is the 2 power 7? 128. All right. Okay. 128. So what that's mean? If you see here, since the first byte in the class A define the network ID. So the first byte is define the network ID. And the leftmost bit should be always 0. Clear? So I have 8 bits. However, the first one always 0. This one I cannot change. Then this 7, it's cannot change or cannot define network. This 7, when it's 1111, what's the answer will be? 127, not 128. If you add them, it's going to be 127. Perfect. So next 7 bits can find the number of the blocks in this class. And when you have 2 to the power 7, I'm sorry, don't 2 to the power 7, we'll have 128 blocks. That's mean we start from 0 to 127. So how many networks I can have there? 128. And the first network is, the address is 0, and the last one is 127. Okay. So, and how many hosts in each block I will have? Remember, the IP address is 32. I used 8 for the network ID. How much left here? So how many hosts I will have? 2 to the power of 24. And it's going to be how much? 16 million hosts for each block. That's mean if you look at the class A, okay, from the class A, I can have only how many networks? 128 networks only. And each network, how many hosts will has? 16 million something. Okay. Do you think there is an organization has 16 million hosts? No. That's why class A, it's impossible to use, because what you do, you have divide your IP addresses to a small group of networks, and each network has a huge range of IPs. Okay, so maybe you can do that for what? The ISPN providers, and this ISPN providers internally divided to sub network. So when we talk now, we'll go over sub network and super network. You will see what's the difference. So in the class A, how many blocks I will have? How many networks I will have? From 0 to 127 networks. And the first network, the IP address starts with 000 and it's end with 255 to 55 to 55. Okay. Second block, what is 1 and it's end with 255 to 55 to 55. Okay. The last one is 127 and it's give you up to 16 million. All right. So from here, what you can tell me about class A? Millions of class A addresses are wasted. Simple. So nobody using class A. Now let's go about class B. Let's before I go there. Now class B, let's do it here because usually easier. So class B, what we say the class B, how we divide the network ID, net ID and host ID. How many bits we need here? We have 24, correct? No, 16. We'll have 16 and 16 here, correct? Because we said the first 2 bytes in the class B, it's for the network ID. Now, let's go about this first 16. In the class B, how many bits always has to be fixed? 2, which is always has to be 1 0. So how many bits left here to change? So the first two always has to be 1 0. And how many left here to keep changing? 14. How many networks then I can use here? 2 to the power 14. Okay, network. How many hosts for each network? Number of hosts in each network. Equal? That's a host ID. So how many networks? 2 to the power 16. All right. So let's go there. Since 2 bytes in the class B define the class, and the 2 most left is going to be 1 0, as we said. Always has to be 1 0 for a class B, correct? Always 1 0 there. How many bits it's going to help us to define the number of networks? Is only 14 bits. And how many networks we'll have? 2 to the power 14 is 16,000 something networks. So there is improvement. We start from how many networks in the class A? We had only 28 networks. Now, how many now we have? 16,000 plus. Okay. And each network, how many hosts you can have? 65,000 plus. Okay. Still, do you think there is a company has 65,000 hosts? Maybe. I don't think so, but maybe. But there is improvement. Okay, that's why, if you remember in class A, start with 128, and the last one is 192. All right, so that's a class B. Now, again, the same issue. Many class B addresses are wasted. You assign a company with 65,000, and this company size is 200 hosts. So you're wasting the IP addresses. Okay. What is the third one? Class C. What is the class C? Just remind me. How many bits for the network ID? 24. How many bits for the host ID? That's network ID, and that's host. It will be 8. Okay, how many bits always fixed? Okay, the first 3 always has to be, remind me, 110. How many bits left to change? 21. Correct? 24 minus 3, 21 bits. So how many hosts we will have? Number of hosts. 2 power. I'm sorry. Number of networks. 2 power of networks. 121. Okay. Then you will have a number. Number of hosts. 2 power 8. This one equal 256, correct? From 0, remember, from 0 to 255. Okay, the total will be 256. Clear? So now let's go to class C. Let's see if what we explained is correct. So remember, for the network ID, we use the first 3 bytes. And the first 3 bits always has to be 110. So how many bits left for us to define the networks? 21 bits. And how many networks we'll have? Around 2 million networks. So now we divide the IP address range to more networks, okay? And however, how much each network you will have, how many hosts for each network? Okay, 256, correct? Question now for you, is 256 enough? It's enough? Now, UB, how many computers you think you have? How many computers, how many routers, how many switches, how many, what else we will have? Projectors if it's connected to the internet, how many phones, how many? So 256 is not enough, okay? So what's the issue with that? Class C is too small for some companies. Maybe a small company, they will have 20 employees, 50 employees, that's enough for them. But if you have, a good size organization, I remember when I used to work in Yale, Yale Hospital, we had around 10,000 machines because they have 7 hospitals. So 10,000 machines. That's not include the switches, IBs, everything, AB. So it's a lot. So is class C is gonna be enough for? No, it's not gonna be. That's why we'll cover it now. We have a concept called subnetting and supernetting. What is the subnet or subnetwork? So, for example, if you have a class, if your network is a class B, okay, and which is too big, what you can do, you can divide it to small networks. All right, and that's what's happened now. The internet provider, they will have a range of IP addresses, big range, and then they divide it to the local ISP region. First we'll have the big company, the main company will has all the IPs. Then they assign specific IP address to small, local providers. Like, you have Verizon, you have Optimum, you will have Crown Castle, all this company. They will have a small sub network. And even this small organization or companies, they have their own sub network. Okay, that's to divide make the big network to a smaller network. What about the super network? The super network, for example, you have a class C network and it's too small. 255 is not enough for you. So what you can do, you will have 3 of the class C network and you combine them somehow, then you will have a bigger network. Now, instead of 256, you will have 1,000 machine. Okay, so that's the super network. Okay. Okay, not so many organizations are small to have a class C. That's the issue. All right. So then, as we say, we have one block for a class D and one block for a class E. And there is just one block for D, and this is designed for multicasting. Simply start with the 224 up to 239, and of course everything zeros. Class D addresses are made of one block used for multicasting. What about class E? Same thing, it's one block, okay, and it's used for what? It's not used, it's reserved, okay, for a future purpose. Okay, Again, for IP addresses, there is an organization. There is organization in charge of the IP addresses. You know, you cannot just go and decide, oh, I need this IP address. This is not up to you. So we have you know, non-profit organization handling that. All right, so that's why this one is for reserved for the future. Okay, the range of addresses allocated to organization in a class for addresses where block address ABC, as we mentioned before. We can use only ABC. We cannot use D, you cannot use E. Clear? Okay, guys, let's take a break. Let's take a break for 5 minutes, and then I'll come back.